In some of my previous videos, we talked about functions, what they were, and how to evaluate them. Well, this video is part one of a two-part series on how to handle functions when you are asked to perform operations such as addition, subtraction, multiplication, or division between two functions. We'll go through examples of all four types, and in part two, we'll talk about composite functions. So, without further ado, let's get started with operations on functions. For our first example, we have here the function f plus g of x, and we are given the function f of x as 3x plus 4, and the function g of x as 7x minus 6. If we're being asked to add the functions, all we need to do is take our f function and add it to our g function. So we're going to have 3x plus 4 plus 7x minus 6. And we got to make sure that we combine like terms, so my x's add to my x's, my constants add to my constants, and I'll get the end result as f plus g of x. So we have 3x plus 7x, which gives us 10x. That's a terrible x. There we go. And we have 4 plus negative 6, which is negative 2. And this is our answer. That literally is all we have to do. Works out pretty nicely. The only way we could change this to make it maybe a little bit tougher is that instead of it being f plus g of x, we could replace this with a number. So we have a value for x. So if, let's say it was actually f plus g of 3. Well, after we add our functions together like we did here and get 10x minus 2, now we can rewrite it as 10 times 3, put 3 in for x, minus 2, and that's going to give us 30 minus 2, which is 28. And all the functions that we work with today will work like this. If they put a x in the parentheses, you're just being asked to perform the operation, addition, subtraction, multiplication, or division. If they put a number inside the parentheses, after you do whatever operation there is, evaluate it at that number. Not too bad, hopefully. Alright, let's try a different example. For our second example here, we're taking the function f minus g. So we're going to take the function f of x, subtract from it the function g of x, and order does matter here. Gotta have f of x first. And then we're going to evaluate it at 4. So, if we set it up, we'll have x plus 6 minus, since we're subtracting them, and I'm going to put a parenthesis here since I got a negative, negative 2x plus 7. Alright, so this is going to tell how good we are with our subtracting negatives, because notice I have a negative and a negative here. Got to keep that in mind. So when I combine all these together, I'll have x minus a negative 2x, which actually means you're adding it. So we have 3x, and then I have 6 minus 7. So that's going to give us a negative 1. Now, I have to evaluate it at 4. So I can plug in, we've got 3 times 4 minus 1, which gives us 12 minus 1, which is 11. So our answer for this example, if we were subtracting the functions from each other, is just 11. Hopefully, not having too hard of a time with this so far. Now let's get into ones that could be a little trickier, multiplication and division. Alright, this time we see the little dot in there, so we know that this is multiplying the function of f times the function of g, and we don't have a number inside our parentheses, so we're going to leave it in terms of x. Now, all we got to do is just multiply f times g. And you got to be careful with these because depending on what your functions are, you might be able to just distribute normally, or you might have to use the FOIL method or the box method, depending on if you have more than one term over here. To make it simpler, I just kept it with one term, so we have x squared times, and I'm going to put g of x in parentheses, x plus 4. and we're being asked to multiply. All we got to do is distribute the x squared to each part. So we're going to have x to the third plus 4x squared. And we're done. Since we didn't have a number inside here, we don't have to evaluate it at anything. All we had to do was multiply them together. Now, but what if I do have two terms here? So let's erase this real quick and try it a little bit differently. Let's say my f of x is actually x squared plus 4. Well, then I'm going to have x squared plus 4 times the quantity x plus 4. And this is going to give us an opportunity to use our FOIL method, because I have to distribute the x squared to everything and the 4 to everything. So let me put in my arrows. I got x squared times x squared times 4, 4 times x, and 4 times 4. So when I multiply these out, I'm going to have x to the third plus 4x squared, just like I started off with before. But now I have to do the other multiplication. Plus 4x plus 16. And this would be my final answer, since I'm not being asked to evaluate at any specific value of x. Alright, our last one. Let's take a look at it. It's division. Alright, for our final example, we're being asked to divide the function of f by the function of g, and we're keeping it in terms of x for right now. Now, in some cases, this could be one of the easier ones to do, but there is a very important topic that we need to talk about, which is excluded values. Excluded values. So I'll bring that up once we run into it. So, as it looks like, we're just going to make a fraction out of our two functions. F goes on top, g goes on the bottom. So that'll give us what? It'll give us 4x on top, 3x plus 1 on the bottom. And sometimes we'll have to simplify this, but in this case we really can't. So we would just leave it as 4x over 3x plus 1. But this is where the excluded values comes in. What is an excluded value? It is a value for x that we cannot include in this. And the reason for that is when we have a fraction, the denominator can never be 0. So we have to figure out what can x not be so that this denominator won't turn into 0. And it's not too tough to figure out. We take the denominator, which is 3x plus 1, and we set it equal to 0. Then we solve for x. So we subtract 1. We have 3x equals negative 1. And then we divide by 3. So x is negative 1/3. If x is negative 1/3, this denominator is going to become 0. It doesn't matter what happens to the top. If the denominator becomes 0, it's terrible. So we have to add in this excluded value. And here's how we do it. Let me erase this real quick. We say that a function of f divided by the function of g of x is 4x over 3x plus 1. But then we have to add this little text here, x cannot equal negative 1/3. Because if x equals negative 1/3, like I said, we're going to have 0 in the denominator, and that would be bad. So, f divided by g of x, not too tough, just create your fraction, but then also figure out what is the excluded value. Let's try one more to show how sometimes we can simplify this, and then that'll be it for this video. Alright, here we have 12x as the function is f of x, and the function g of x is 3x plus 3. We're still doing our division operation, so f divided by g. So let's set it up. We've got 12x on top, and we have 3x plus 3 on the bottom. And we could leave it like this, but it's always best to simplify if we can. And if we notice, down here, both terms have a 3 in it. So I can get a greatest common factor of 3 and factor that out of the denominator. So I'm going to have 12x over 3 times the quantity x plus 1. All I did was pull a 3 out of each term, and if I were to multiply and distribute that back in, I would still have my 3x plus 3. And now I can divide a little between these two. I can say 12 divided by 3 is 4. So my simplified term here would be 4x over x plus 1. So we want to be able to simplify if we can. Sometimes we might have to use synthetic division or long division with these, but sometimes it's as easy as pulling out a GCF. But don't forget, just because we've factored and simplified it down doesn't mean we're done. We still need to worry about an excluded value for this. So let's erase some of the original stuff so we have a little more room. And I need to figure out what the excluded value is for 4x over x plus 1. Just like last time, we take the denominator and we set it equal to 0, and then we solve for x. So x would be negative 1. That means in the denominator, x can never be negative 1 because that'll give us 0 here. So our final answer, and this is the last example we're doing, so the final answer for this video is if we want the function of f divided by the function of g, it is, for this case, 4x over x plus 1, and x cannot equal negative 1. In our next video, we'll talk about some composite functions, but hopefully this gets you off to a good start with operations on functions.